Hello students, today we are going to be looking at an introduction to exponents, which is lesson 2 of our unit. So if we are talking about multiplication, we all know back from our early days of math that multiplication is simply sped up addition. So if we were looking at adding 2 plus 2 plus 2 plus 2 plus 2, an easier way to do that is to simply use multiplication and to do 2 times 5 because we're adding 2 5 times. So when we want to add many of the same number together, we can speed up the process through multiplication. So you want to make sure you understand that concept. If you need to pause it and take down some notes, please do so. Moving on, now onto exponents. Exponents is simply a way to speed up multiplication. So if we are looking at multiplying 3 times 3 times 3 times 3, exponents enable us to speed up this process. So we can do 3 to the 4th power, and that just simply means 3 times 3 times 3 times 3. So just as multiplication speeds up addition, exponents are also going to speed up multiplication. So I know exponents might be something that is relatively new to you, so what we are going to do is we are going to look at exponents and the parts of a power and break this up for you so you understand it a little bit better. So please take down some notes on this slide for our definitions. So when two or more numbers are being multiplied, each number is called a factor. So these 7 times 7 times 7, the numbers being multiplied together, are called our factors. An exponent is used to show how many times the factor or the base is being multiplied. So our 7 is our base. That is the number that is being multiplied. The 3 is the exponent because that shows us how many times to multiply the 7 together. When we write out all the factors separately, that expression has now been expanded, and that is known as expanded form, and you'll be asked to do that in some upcoming examples. So, if we look at some upcoming examples, expand and then simplify. In example 1, 7 to the 3rd power, that is exactly the same problem that we were just looking at when we identified the parts of the power. So we know to expand 7 to the 3rd power, that simply means 7 times 7 times 7. We wrote out all of the factors. And 7 times 7 times 7 is equal to 343. So that is your simplified answer. We can't simplify that any farther. 1/2 to the 4th power. Well, if we expand it, that means we're going to take the fraction 1/2 and multiply it by itself 4 times. And when we simplify 1/2 times 1/2 times 1/2 times 1/2, that is equal to 1/16. So our simplified answer is 1/16. 8 to the 1st power. Well, that simply just means we're going to multiply 8 by itself one time. So I'm only going to write 1/8. That answer is already simplified. I can't simplify that any farther. So 8 to the 1st power is simply just 8. 0 to the 5th power. 0 to the 5th power means that we're going to take 0 and multiply it by itself 5 times. 0 times 0 times 0 times 0 times 0, we all know is equal to 0. Anything times 0 is equal to 0. So that's how we simplify with exponents. Something that you have to be very, very, very careful about is identifying the base. So in this case, I have 4 yellow boxes across the top. And I want to know what the base is for each of those yellow boxes. When you are looking at the base, it is what comes directly in front of the exponent. So directly in front of the exponent, or to the left, is the number 3 in the first box. So our base is just 3. In the second yellow box, the parentheses join together the negative sign and the 3. So the base in that case is everything inside the parentheses. It is the whole negative 3. In the third yellow box, we have a negative sign outside of the parentheses. So the only thing that is considered the base in this example is the 3 that is inside the parentheses. And then in the last yellow box, again, there's a negative 3 inside the parentheses. There's also a negative sign outside of the parentheses. The only thing that is the base is what is inside the parentheses. So that negative 3 is the base in that final yellow box. Make sure you understand that and you have that copied down in your notes. So examples 5 through 8, we're going to look at each one of those bases and we are going to simplify using the exponent of 2. So in the first example, we have negative 3 squared. So remember, our base is simply just the 3. So that's the only thing that I am going to square. So I'm going to write my negative sign out front and multiply 3 times 3. The base is the only thing that gets multiplied together twice. Well, we know 3 times 3 is 9, and we want to make sure we bring down our negative sign, so our final answer is negative 9. Now in example 6, this is looking at the second yellow box, negative 3 in parentheses squared, we said the base was negative 3. So we are going to multiply the base by itself twice. So the base negative 3 times negative 3. Negative 3 times negative 3 gives us a positive 9. In example 7, the negative sign is outside of the parentheses. The 3 is inside the parentheses, so my base is just the 3. So I'm going to keep my negative sign outside. 3 times itself, 3 times 3, is equal to 9. And we have to bring down the negative sign, so our answer is negative 9. In example 8, this one's a little bit trickier. We want to bring down the negative sign that is out front. Our base is negative 3 because that's what is inside the parentheses. So I'm going to multiply negative 3 by itself twice. If we simplify this, we know that negative 3 times negative 3 is a positive 9. But we have that additional negative sign out front, so we have to bring that down, and our final answer is negative 9. So when we have negative bases, this is going to be very important. Make sure this is in your notes. If you need to pause the video, please do so. A negative is part of the base only when the negative sign is inside the parentheses, and we saw that in the last 4 examples. The base is always the number or the group that is immediately to the left of the exponent. So group meaning what is inside the parentheses. So examples 9, 10, and 11 is looking at this very important rule. Example 9, we have negative and then a parenthesis 5 and parentheses square. So our negative sign is not inside the parentheses, so that is not part of the base, so that negative sign is going to stay outside. And we are going to square 5, so we have 5 times 5. And 5 times 5 is 25, and we have to remember to bring down our negative sign for our final answer. If we look at example 10, negative 5 in parentheses squared. Now that negative sign is part of the parentheses, so we are going to include that in our base. So it is negative 5 times negative 5. Negative 5 times negative 5 is a positive 25. In example 11, negative 5 squared. That negative 5 is not inside parentheses. So the only thing that is considered the base is the 5. So we bring down our negative sign, and we do 5 squared, which is 5 times 5, which we know is equal to 25, and we bring down our negative sign for our final answer. Moving on, now we are going to be simplifying using the correct order of operations. So remember, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So if we look at this in example 12, 3 times 6 plus 2 squared, we want to do what's in parentheses first. So 6 plus 2 is 8. And we have to remember to bring down our exponent. 8 squared is what we do next, exponents. So 3 times 64. 3 times 64 is 192. So I want you to try example 13 on your own. Take a few minutes, pause the video, do example 13, and please bring that example into your teacher to see if you got the correct answer. We will check that for you in class. We are going to move on now to example 14. And we are going to evaluate expressions again for given values of the variables. And we're going to do this just like we did evaluating expressions in the last lesson. So everywhere we see an x, we're going to substitute it with a 2. Everywhere we see a y, we're going to substitute it with a negative 3. So 5 times 2 cubed times negative 3 squared. And it is very, very important that you put that negative 3 in parentheses because that is the whole base. Anytime you are substituting numbers in for variables, you want to put them in parentheses. We're going to simplify our exponents first. So 2 cubed is 8. Negative 3 squared, negative 3 times negative 3 is 9. 5 times 8 is 40 times 9, and our final answer is 360. Example 15, we're going to do the same thing. Substitute negative 1 for A, negative 4 for B, remembering to put these values in parentheses. So 2 times negative 1 in parentheses squared minus negative 4 in parentheses cubed. Following order of operations, exponents first. Negative 1 squared is just 1. Negative 4 cubed is negative 64. Now we need to simplify multiplication. 2 times 1 is 2. It's a good idea to change our double signs here, negative negative, to a plus 64. 2 plus 64 is 66, which is our final answer. 2 more examples to look at. Simplify using the correct order of operations. Negative 1 to the 228th power. Now you may be thinking, I can't write out negative 1 228 times. But if you look at this, if we do negative 1 times negative 1, that gives us a positive 1. 228 is an even number. So anytime you see an even number as your exponent, you're always going to get a positive answer. So negative 1 to the 228th power is going to be a positive 1. If you notice, example 17 is an odd exponent. Well, if we look at our first odd number other than 1, which is 3, negative 1 times negative 1 times negative 1, we know this gives us a positive 1, negative 1 times negative 1, and then times our other negative 1 gives us a negative 1. So this odd power will always give us a negative answer. And I have some rules for you to copy down. You can pause the video and copy these down. Negative base to an odd power will always give you a negative answer. A negative base to an even power will always give you a positive answer. And if you remember those 2 rules, you should never make a sign mistake in your answer. Thank you for watching.